So I'd like to welcome you to my talk, Java Deserialization, Vulnerabilities, the Forgotten Bug Class. My name is Matthias Kaiser. Before we start, I want to give you a short introduction to me. I'm currently the head of vulnerability research at CodeWhite. CodeWhite is a small pen test company and security research company. We are between Munich and Stuttgart, and we're only doing red team pen tests and looking at products for bugs. I used to be a dev in the past for a defense company, but realized in the end, okay, security is cool. I want to do that a lifetime. I spent a lot of time on Java security, especially server-side security in the last 2 years. For the ones who are familiar with Java sandbox escapes, there are some modules in Metasploit. I wrote most of them. I found bugs in products of Oracle, VMware, IBM, SAP, Symantec, Apache, Adobe, HP, so all the big vendors which are using Java as their software stack. But recently I'm showing more Windows stuff and also client-side like Adobe Reader. Okay, that's about me, and the agenda for today is this. So I will start with a short introduction into the Java deserialization apocalypse. I will talk about the Java object serialization, how it works. Then we will look at what the problem with it is. I will look in the past about the history of bugs, which have been there for about 10 years. The most interesting part will be finding and exploiting the bugs. We will also look at the CodeWhite bug parade, so all the bugs which we found during our research time. And I also have a hands-on example. So the ones who have seen my presentations in the past, I always have some nice real-world examples. O-days. And the last thing will be, is there more to come? Okay, let's get started. I think one of the most interesting questions which you may ask yourself is, should I really care? And I think this question is already answered because you have been following Twitter and all the security world. But if you're a pen tester, for example, and if your client is running one of those products, you should really care about it because all of them are affected by it. All big vendors. And I also have some facts for you. So first of all, the bug class exists for more than 10 years now. In my opinion, it's the most ignored bug class at all in the server-side Java world. It's an easy way to get reliable code execution on the server side. Since it is Java, it's architecture independent, so it doesn't matter if it is Linux or Windows. You just get a shell. And from our experience of the red team pen test we did is that with Java deserialization vulnerabilities, you can own a corp very easily because you always find in the internal network a RMI listener running on port 1090 or 1099 or 1098. And then you get hopefully a Windows system, and then you can start with the lateral movement. So where is RMI used? There are some core where's Java deserialization used? There are some core technologies, for example, the old and ancient remote method invocation. It should have been never used at all because it's just sending around serialized objects, but still you can find applications using it. We have the Java management extension, JMX. It's usually built on top of RMI, so it's also vulnerable. We have the Java message service, JMS. It's a specific topic in my opinion because it's about Java messaging. I have given a talk at Black Hat this year about how you can exploit the Java message service. I also have written a tool called JMET, Java Message Exploitation Tool, so if you're interested, you may look at the slides or also the tool, how it works. Java serialization is also used in server-side components, which are called Java server faces. It's old stuff, but still people use it. For example, my faces, rich faces, ice faces, they were all affected by it. And they were storing, for example, the current state of the browser in the view state, which was stored in the cookie. So you just send a cookie to the server and you get remote code execution. In general, whenever two VMs are communicating to each other, chances are very high that serialization is used because, as I said, I was deaf in the past, so I'm allowed to say that devs are lazy. I also did it in the past. And of course, there are custom application protocols, for example, on top of HTTP, where you are sending serialized objects in the HTTP body, for example. Before we get into details, I have a short clarification about the names. So whenever I talk about serialization, I mean the process of taking the current state of an object and represent it as a stream of bytes using the Java serialization protocol, and then store the bytes, for example, in a file or in the database, or send it over a network. And when I talk about deserialization, I mean taking the serialized object stream, so the bytes, and reconstruct the same object again using the serialization protocol. I have a very short example about the serialization protocol of Java. I have a class conference. Conference, we have two members, name and start date. Name is of type string, and start date is of type date. And I created an instance of it, and I wrote a serialized representation of it into a file. And the content of the file is the following. So a serialized object stream always starts with the header ACED. So whenever you see ACED somewhere in a file in the database, on the network, in Wireshark, wherever, you know it's RMI, it's a serialization, and you know what to do, exploit it. Then we will continue with the version number, it's 0005. Then we will start with the TC object, which means, okay, there will be an object, and then the next will be a TC class description, which will mean the following object has the following class description. So in our case, the class name is DE code wide conference. It has two fields, name and start date. Name is of type string and start date is of type date, and all together form the class description info. And then we will get the values in a class data array. So the first value will be of type string and DeepSec, and the next one will be of type date, and the date represented as a long, which is 8 bytes in Java. And that's it. It's a serialized object. If you're interested more into the protocol, there's a very good web page from Oracle about the object serialization stream protocol. You can look it up. They also have a grammar for it, so if you want to implement a parser or a generator, you can use the grammar for that. It's very well defined and very good. If you look at the programming side, how deserialization looks like in the code, it's pretty simple. So typically, you use any input stream you can find in the JDK or in your libraries, and you use the input stream, for example, file input stream, byte array input stream, socket input stream, whatever, and you use it as a source for object input stream. So constructor and then as a parameter. And then you just invoke the read object on the object input stream. That's it. That's deserialization. That's a deserialization vulnerability if it's coming from untrusted data. And I think one of the first questions you may ask yourself is, what could possibly go wrong here? And there are several things which can go wrong here. First of all, the object input stream class does not include any features to validate. So you cannot say, okay, I only want to allow to deserialize specific classes from a specific package. It will always deserialize. And the next big thing is all classes which the current class loader can locate, which can be, for example, about 200 megabytes of zip files. In case of Oracle WebLogic, you will find, for example, about 30,000 classes in Oracle WebLogic, and all of them are in the current class path. They can be located, so you can reuse them for creating nice gadgets. And although a class cast exception might occur in the very end, it doesn't matter because the object will be reconstructed completely, and then the class cast exception will occur, for example. So it doesn't matter. You will get a log entry, and that's it. The second problem, which is in my opinion also a very major problem for the developers, is that a developer is able to customize the behavior of serialization and deserialization. There are some magic methods, I call them. It's write object, write replace, read object, and read resolve. And for example, read object and read resolve are called during the process of deserialization. And I also created a very artificial example for you. It's called file cache entry. It implements the serializable interface. It has two members. One of it is entry, which is of type byte array, and the other one is path of type string. And now think about a Tomcat web application, which is deserializing data from the HTTP body. and you have such a class like file cache entry in the class path of the web application or Tomcat, and what you can do is you create an instance of that and deserializes, and what you do is you just write into entries the data which you want to write. And in the path, for example, the path to the web application or to the Oracle examples web application and a JSP file. And what will happen is that when you send it to the server, it gets deserialized. The read object method will be called. Then the default read object will read in all the values for the members, which means, okay, it will read the byte array from the stream, and then it will read the path from the stream. The next step will be, okay, let's create a file output stream for the path, and then write to the output stream the entry. So you can write a JSP with that and get code execution. And this is a very artificial example, but there have been classes like that. For example, if you have ever heard about Commons file upload, it wasn't that easy at that one, but still it was somehow similar that you could specify the data to be written and also the path. You need to use a trick, for example, null byte, but it was almost the same thing. And by using such classes, you can exploit it. Yeah, as I said, and those are under control because they are coming from the input stream, from the object input stream. And the third problem is, in my opinion, that you can create huge chained objects using trampoline classes. For example, if you want to invoke a toString method on a serializable class or object, you can call the bad attribute value exception, because what will happen there, it will call in the very end a toString method on any object which gets deserialized. Or if you want to call the hashcode method, you can use hashmap. Or if you want to invoke a comparator and the compare method of it, you can use the priority queue. So as I said, it's a trampoline. You just deserialize a hashmap, and what will happen in the read object, it will transfer the code execution or the call to another object, which is great. I have also an example for that. It's from the bad attribute value exception. The read object is very easy. It just reads a field val from the object input stream, and in the very end, if no security manager is running, it will call on the object, so it's of type object, the toString method. So you are able to call a toString method on any serializable object, which is really very helpful for creating gadgets. Those are, in my opinion, the core problems with it. So missing validation, the class loader thing that all classes are available, which you can reuse for create your exploits, and also that you can create large chains. And you might think, okay, sounds reasonable, this should be known for years. No, it's not. If you look at the timeline, so the first one who was ever talking about deserialization vulnerabilities was Mark Schoenefeld, one of the godfathers of Java security. And he was able to create a denial of service attack by sending a serialized object which implemented more than 32,768 interfaces. And what will happen in the JVM, it crashed because there was a wrap overflow. Yeah. The next one who was talking about it was Luca Caritoni. He was able to create a denial of service or XSS in Java Server Faces implementation. The first one who was able to show that you can also use it for remote code execution was Wouter Kökertz. He was exploiting a very common library, which is Spring. The next one was Pierre Ernst, at that time working at IBM. He found also another vulnerability in IBM Cognos. Then we had, again, Pierre Ernst with a couple of vulnerabilities in open source products. We had Takeshi Terade in JBoss rich traces. And then in 2015, suddenly Chris Frohoff and Gabriel Lawrence showed some very nice exploitation techniques, though I guess you already know it, the Commons collection, and also the Groovy. I think this was the starting point for all the researchers to look at, also for me. And since then, Java Deser, I think it's one of the new hotness. So as I said, Chris Frohoff presented their research at AppSec Kali in January 2015. They talked about, I think, Python, Ruby, and Java. And when I looked at the slides and I saw the commons collection gadget, I thought, are you guys serious? You're dropping this at AppSec Kali? Commons collection can be found everywhere. It's just great. It's awesome. Yeah. So I think they weren't aware of the problem at that time. So the next presentation or the next talk was from me at DeepSec. No, at Hacker Practicum. It was exploiting deserialization vulnerabilities in Java. 2 weeks later, Foxglove Security wrote their famous blog post about how you can own WebLogic, WebSphere, JBoss, and Jenkins with deserialization vulnerabilities, in this specific case with commons collection. The next one was Alvaro Munoz and Christian Schneider at RSA. Then we had Chris Frohoff again at Obersk, San Diego. Then again me talking at Infiltrate about deserialization vulnerabilities. And then we had again Alvaro talking about JVM serialization. So he generalized it and was also looking at other languages which are running in the JVM. And then again it was me about talking the Java messaging service at Black Hat. Okay, so, and in my opinion, finding such vulnerabilities so easy. That's why I'm always talking about it at the conferences, because I really want to invite you guys to look for it, because there are so many vulnerabilities. Finding is just a grab if you have the source. And I mean, if you have server-side Java code, you always have the source because you can decompile it. It's not like on Android where they use ProGuard to remove all the scope. So you have the source, you can grab for it. And whenever you see the read object call coming from an object input stream, it's a deserialization vulnerability. So the task is then to find out if it is coming from untrusted data, for example, from an HTTP request or whatever. And then you are ready to go and look for gadgets or reuse existing gadgets. What I usually do is I'm a fan of IDEs. I always use IDEs like IntelliJ, Eclipse, or Visual Studio. Because you have nice features like call graphs. I usually do a right-click on read object of object input stream and let me show the call graph, and then I go through all the call steps or calls and find out where is it triggered. And it's much easier and faster ask grep. Finding deserialization vulnerabilities is easy compared to the exploitation, because for exploitation you need to reuse existing classes in the class path. And such classes need to fulfill some properties. They need to be serializable, and they need to have interesting functionality which you can trigger, for example, from a read object call or a read resolve call, which is writing files, or do dynamic method invocation, which the so-called Java reflection API, so all the classes from the Java Lang reflect package. Such a chain of objects which can trigger interesting functionality is called a gadget, like a ROP gadget, but much easier. And Chris Frohoff and others found a lot of gadgets, or I wouldn't say a lot, but let's say several, which you can use. And they are in third-party libs, which are very well known. I also found some gadgets. One of it is the JavaScript word gadget. I used it when I reported the WebLogic T3 vulnerability to Oracle. So the T3 protocol is a very old protocol which is supported by every WebLogic version which you could find. It's a custom RMI protocol, and I reported it to Oracle together with the commons collection exploitation technique and also with the Java assist word gadget. And what it allows you is to call a method on a deserialized object. So a method which does not have any parameters. That's it. I have also another one. I call it the return of the Rhino gadget, because the Rhino script engine, which is used for interpreting JavaScript in the JVM, was also used, for example, for sandbox escapes in the past, but you can also use it as a gadget on the server side. And this gadget works if you have the latest Rhino in the class path, or if you're running a JRE version 7, which is bundled, for example, in Debian or Ubuntu, because they have an unpatched version running there. Because the patch which was introduced for the sandbox escape also fixed the gadget, but they didn't incorporate the patch into OpenJDK 7 on Debian and Ubuntu, so they are still vulnerable. And it's a JRE gadget, which means all the classes which you will reuse for exploitation do exist in the Java runtime environment itself, so you do not have any dependency. So every application will be exploitable using that gadget. Currently, we have about 3 JRE gadgets, not more. What to look for, as I said, look for serializable classes, working on files, triggering reflection calls, doing native calls, and find out if you can call them from a read object, a read resolve, or a toString, or a hash code, or finalize, or any other trampoline class you can find. And there's also another thing which you really should look for, which is proxies. Java has the concept of proxies. It's similar to the ECMAScript 6 proxies, where you say, okay, I have an interface, and I have an invocation handler, and I create a proxy for that interface, which will handle all method calls for me. There are currently 2 techniques. You can use the invocation handlers from the Java runtime environment, or for example from Java Assist, which have their own implementation for that, which are called method handler. And as I said, what will happen is, if you create a proxy, the toString method will go from the interface to the invocation handler. And I have an example for you. It's the example invocation handler. It implements the invocation handler interface. It is serializable. It needs to define or implement one method, which is the invoke method with 3 parameters, proxy, method, args. And what will happen in this invocation handler is just print out which method called, and that's it. And now let's create a proxy. Let's say we want to have a proxy for a map interface. We use the example invocation handler. We create with the proxy new proxy instance a proxy which implements the map interface. And when we call the toString method on our proxy, what will happen? Method toString is called. And there are a lot of invocation handlers out there. For example, if you want to do something like AOP, aspect-oriented programming or stuff like that, they're using a lot of invocation handlers. And there have been several invocation handlers in the past which were serializable and could be exploited. Typically because they were implementing stuff like caching, method caching, and things like that, which you could override, and yeah. So look for invocation handlers. If you don't want to do it manually, you can also use a tool from Chris Frohoff. It's called Inspector Gadget. It's an object database. He's using Gremlin. And what he will do is he will index all the classes which you have in the class path. And then you can write queries and find out, for example, which class is implementing serializable, and also have a method read object. So give me all classes that implement serializable and have methods read object. And then suddenly you get all the methods, all the classes which have overwritten the deserialization behavior, which is a good starting point. So let's say you're able to find a class where you can call a method on a serialized object or deserialized object without any arguments. Then the next question will be, how can I turn this into remote code execution? There are some tricks for that. First of all, it's the Adam GoTheX templates inbuilt trick. Adam used it, so he's, I would say, the godfather of Java security. He used it for sandbox escape. And the templates inbuilt class is very, very interesting. It's from the Xalan package of Apache. So it's used for XSLT processing. And it's serializable, and it has one member field, which is a 2-dimensional byte array. And whenever you invoke a new transformer method on a templates inbuilt class, what will happen is the following. It takes the bytes from the byte arrays and defines a new class taken from the bytes, and it creates a new instance from the class. So which means is the bytes define the code which you will run, and then the new instance call will run your code. So you just create a class with a default constructor, and you write down runtime get runtime.exe, and what will happen is in the new transformer call, you get code execution. That's, I think, the tricks which is almost always used in the gadgets you can find. There's another one. I call it the initial context.lookup trick. It was initially found by Ben Murphy for a sandbox escape in 2013. Zero Thoughts published a blog post by exploiting this trick in the JTA transaction manager. It's a class from the Spring library. And what will happen there in the read object call, it will do a initial context.lookup and will take a JMDI name. So a name, for example, to an RMI server. And what the initial context.lookup will do is will try to connect to the RMI server. Then if you have a special RMI server, the RMI server will return a reference to a HTTP server, and then classes will be downloaded from the HTTP server, and the classes, from the classes a new instance will be created, so you have again code execution. And the initial context.lookup trick can be also used as in a gadget, which is the JDBC rowset_impl class of the Java runtime environment, and whenever you invoke the execute, connect, or several other methods, it will do initial context.lookup with a JNDI name you can specify, and then it will try to connect to your RMI server. Those are two tricks. I will also present another one today. But if you say, okay, that's too deep for me, I don't want to stick around with Java stuff, let's get me a shell. There's an easy way for that. There's a tool from Chris Frohoff. It's called Why So Serial. And what it is, it's just a payload generator for all the gadgets which exist. Currently, we have about, I think, 10 or 12 unique gadgets and several variants from, for example, Commons Collection. So about 16 gadgets at all. And Why So Serial includes Commons Collection, 3 and 4, Spring, Groovy, JRE gadgets, Common Bean utils. So all of them are very common libraries you can find in server-side applications, which you can reuse. And the payload generation looks like this. You just run Why So Serial, java-jar, path to Why So Serial. You specify the gadget you will have to create a serialized object stream. You specify the command which you want to run. And if you hex dump it, you see, okay, ACED, that's a serialized object stream. And then you can just use the serialized object stream, for example, to put it in the HTTP post request, and then you get code execution on the server. For the ones who are doing a lot of red teaming, I really recommend not to do runtime, get runtime.exe as Why So Serial does, because you will touch the disk. And with deserialization vulnerabilities, you have the chance not to touch the disk. So you can use, for example, scripting languages, and Java has support for JavaScript. So you can run JavaScript within the JVM, and from JavaScript within the JVM, you can also, again, call Java methods. So you can work in both worlds, which is great. And I always use JavaScript to run my code. For example, I have a meterpreter which only runs in memory. So in Java memory. And so you can use JavaScript, you can use Groovy, Bean Shell, and you won't touch the disk, because for the ones who are familiar with incident response, whenever you do runtime get runtime.exe, you will leave traces in the prefetch. That's it about how to find and exploit it. Now we'll look at the code-wide bug parade. So one of the first bugs we found was in Symantec Endpoint Protection Manager, so the server-side management software for the Symantec AV, which is good, because if you have the AV, you can own the domain very easy. Then we have found a remote code execution Atlas and Bamboo, which is a continuous integration server, Commvault Edge server, Apache ActiveMQ messaging server, Oracle WebLogic. That's also the one which Foxglove dropped at the blog post. HP Service Manager, Spring AIM QP messaging, Oracle Hyperion. It's in BI software, Oracle WebLogic again, which is a blacklist filter bypass, Oracle WebLogic again, which is a blacklist filter bypass. Then I have a bunch of bugs in Java messaging. That's from the presentation I gave at Black Hat. I guess all messaging vendors are affected by it, and that's also true because the vulnerability is already defined in the specification of the Java message service, because they have something like an object message, and you can send a serialized object over messaging. That's the problem, and all of them did not implement any validation. Okay, and I think now it's time for a hands-on example. And you might already know the product which I'm talking about today from the icon. It's CloudBees Jenkins again. CloudBees Jenkins is it looks like this. It's a build server, or continuous integration server, or automation server, or build server. It's created by Kosuke Kawaguchi. He's ex-Oracle and now working as a CTO for CloudBees. It is a fork of Oracle Hudson's CI server. It supports Subversion, Git, Mercurial. It runs Maven, it runs Ant. It has about 1,200 plugins. And yeah, it's an interesting target, especially if you do red teaming, because if you have access to Jenkins, you get access to custom application source code, because usually what happened there is Jenkins will build the code. What it also will do, it will create artifacts like vars, ears, whatever, which will be deployed later on. So you can, if you have a Jenkins, you can place a backdoor there. I've also seen Jenkins instances running directly deploying stuff on servers. So you also get credentials to servers, and you can also deploy. And of course, it stores credentials, either username and passwords or SSH keys, and you can also decrypt the passwords. There's a Python script out there. Just use it, and you can decrypt everything. So it's a very nice target. Jenkins has a special thing. They have a command line interface, and that's also the thing which was exploited by Foxglove in their blog post. The command line interface is running on a special port. I think you guys can't see it, but I will tell you. So when you go on the web page of the Jenkins server, you will get in the response header a X Hudson CLI port header, which will tell you the CLI port of this server is something about 50,000. It can be configured to a random port. It can be a fixed port. And this port is for using a so-called Jenkins CLI client, or CLI client, where you can invoke a lot of actions in the Jenkins server. And if you run this small program, so the Jenkins CLI, it's bundled with Jenkins. There's also a Java Web Start version, so you can run it directly from the browser if you want. And if this one connects, and usually you need to do a login and a username and so on, and if it does not work to authenticate, you get bad credentials. And the protocol which they're using is a RMI protocol, so it's standard RMI just wrapped around base 64, with base 64 encoding. So if you see R0, this is the base 64 encoding of ACD. That's RMI. Or serialization. Okay. CloudBees Jenkins was under attack several times this year and last year. So Stephen Breen was dropping the Commons Collection gadget exploit in the blog post. Then CloudBees implemented a blacklist filter for filtering out gadgets. What will happen is whenever an RMI request comes in, what they will do is they will figure out if any class from the blacklist is part of the RMI call, and if so, it will block it. There was another bypass from Moritz Bechler. Details can be found on the ERNW blog. It's very nice. Moritz Bechler, by the way, has found a lot of gadgets. He's one of the leading gadget researchers, and he was able to bypass the Jenkins blacklist with several gadgets. And as you already, when they already updated the blacklist again after Moritz reported the stuff to them, and as you already know, I mean, blacklisting is hard. It's really hard, so because you never know what is happening and what is somebody sending. So if you look at the blacklist which CloudBees Jenkins is using, it's not that long. We have about 2, 4, 6, 8, say 10 filter statements as regular expressions. So in the very beginning, Google inject will be filtered. It's used for creating a dynamic method called. Those two are for preventing a gadget, which is a bypass gadget for RMI. Bean utils will be blocked. Commons collection will be blocked. The general gadget org Apache Xalan, so the templates inbuilt will be blocked, which is pretty hard. Then we have the Groovy gadget, Hibernate gadgets, Spring framework, several gadgets, and again some RMI. So I thought, okay, how can I bypass this blacklist. And I thought about 3 approaches. The first one, find a new gadget, takes a while, depends on the libraries if they have new or old ones, or have the new ones incorporated. And I thought, no, that will take too much time. I only have 3 days left. Find a bypass gadget would be a chance, but the blacklist is pretty tight, so you cannot invoke. It might work, but I still thought, okay, there might be a better way. And then I thought about, okay, look for a partially fixed gadget, and that's the way I was working. So I looked at all the gadgets which currently Deserial supports. I looked at all the third-party libraries Jenkins was using, and I also looked at the blacklist and tried to figure out what is blocked and what not. And one of the gadgets I really found interesting was the JSON1 gadget. It makes use of the NetSF JSON library, and it has a dependency to the Spring framework, which is bad because this is in the blacklist. And if you look at the call tree of this gadget, hopefully you can read it. It starts with an init step in a hash map read object, and then we'll transfer the control to a JSON object contains value call, and JSON object implements the collection interface. So, and you can call contains value on any collection. And what will happen in the very end of the JSON object call tree is that the default bean processing method will be called with 2 parameters, object and JSON config. And what will happen here is that all getter methods of that object here will be invoked using the Java beans convention. So all getters, all is method for boolean. And as you may see in the very end, a method called getOutputProperties is invoked, which will trigger the template symbol. So with this thing here, you can invoke any get method on a serialized object. And only this one is here blocked. And this is still working. There's no blacklist filter for that. So I thought, okay, let's figure out and find a class which gives me remote code execution by calling a getter method. And the first thing was, okay, there's the JDBC row set inbuilt trick. And it has several methods, get database metadata, get metadata, get parameter metadata, which will call connect. And this will initiate a JNDI lookup with initial context.lookup. So I have code execution. When I tried it out, I realized, oh man, this JDBC row set impl class has a lot of getter methods. And the bad thing is that several getter methods trigger an exception. And after exception, the gadget will jump to the next try catch block and it's over. So this one doesn't work. But there was very good research in the past. A Blackhead presented by Alvaro and Alexander. A journey from JNDI to LDAP manipulation to remote code execution, Dreamland. It's great. If you haven't read it, read it, it's great. Especially for the ones who do Java exploitation. What will happen here, or what they presented there, was that JNDI lookups can lead to remote code execution. We already know that because of the JDBC row set impl initial context.lookup trick. You can exploit it with RMI, but you can also exploit it with LDAP URLs. Not RMI URLs, but LDAP URLs and Corba URLs. And the most interesting part of that presentation was that whenever your application is doing an LDAP query and you have the LDAP server under your control, you can fake a specific response, and this response will either allow you to deserialize data or to download classes from the URLs which are specified in the response by using a URL class loader. So both ways give you code execution, as long as you have the server under control. And you can also use it for exploiting deserialization vulnerabilities, because I found some nice classes in the package com.sun JNDI LDAP, and one of it is the LDAP attribute. And this class is very simple. It's serializable, as you can see from the serial version ID. It has 4 members, dir context, RDN, base context. And what you need to do is you need to create an instance and put your LDAP server, which is your controlled server. So your server running attacker IP, your port, and then you specify an RDN, so that's usually the stuff behind the LWRL, like DC, DN, distinguished name and stuff like that. You can put there anything else you want. And then you need to run your own LDAP server on your system. And whenever the application will do a call to it, you get code execution. And now we can put everything together, almost. So we have a class which is the LDAP attribute, and it has the get attribute definition. Oh, didn't mention it. Here's the get attribute definition method. And what will happen here, it will create a base context, which is a JNDI lookup. And then we will do, it will try to connect. And then the request will happen, and then the response will get code execution. And it's a getter method. So we have almost everything together. We have a getter method, which will give us code execution. The only thing which is missing here is the init step, because this one is not working because of Spring, which is blocked. But I just used Eclipse and looked for an alternative code path, and I found one. We use a flat 3 map from comments collection, which has a read object. What will happen here is it will call a put method, a equals method. Then it will call a contains all on a JSON array, and this will transfer to JSON object default bean processing, which we already know, which will invoke getter methods on that object. That's it. So we have a gadget, or blacklist filter bypass. And I also have some updates regarding the exploitation of Jenkins. You might say, okay, this is not a big problem. It's a CLI port. It's running on. It's not running on 80 or 443, so you cannot exploit it from the internet. That's not true, because there are some hidden GANs in the Jenkins wiki. So when the CLI is not able to connect to the Jenkins server, it will fall back to 2 simultaneous HTTP connections, which means there is a class in Jenkins, in the Jenkins client, which is called full duplex HTTP stream, and it will use one HTTP connection for downloading stuff from the server and uploading stuff. And this can be triggered over HTTP. And the first one blocks until this request is made. So you need to initiate 2 requests. This one will block, and then you need to initiate this request, and then you can exploit it over HTTP. And nobody has talked about that one, about that problem since 1 year. That's new. Because I guess most people say, okay, it's only a CLI port, it's running above 50,000. Now you can exploit it over HTTP or HTTPS. So now it's the time to shut down your Jenkins instances if you have, or tell your clients to do it. Okay, now we have a short demo. I will close my presentation. We will go to my VMware instances. We'll log in. So this is my exploiting instance. This is my target. We have Jenkins running here, as you can see. Let's do it a little bigger. So Jenkins is running. I don't see the URL, but it's running here. Okay, now we are ready to pwn. So here we'll start my LDAP server. It's running on port 10389, and I have a commons collection gadget, which can be used to exploit it, because when you use the LDAP exploitation trick, the blacklist filter does not apply. So you can still use commons collection here. We have started it. I have also a burp running here, that you can see the requests. And now it's time to exploit it. Call the tool called Jenkins Spawner. I will let it run to burp, specify the URL to my instance, and also the LDAP server, which I want to back connect, which is running on my attacker machine. Let's give it a run. We're ready to pwn, so it should be over now. We look here, okay, there's the first request which will block. There's the second request, and as you can see, there's this special base 64 encoded RMI stuff, but there's also serialized object stuff, and there's also the other standard serialized object contained in this request, which is also new. And if you go now to the Jenkins server, you see an Xterm, make Jenkins cry again, powered by code white. And just to make sure if you trust me, So here's the exception from the Jenkins. It's trying to connect to the chain.di server, and it's trying to resolve DEC example DEC.com. I send my bad response, and I get code execution. That's it. This is Jenkins. Okay, and I think now it's time for the last slide. You know, yeah, here are the requests, first one, second one, and conclusion. So on the very end, Java deserialization is no rocket science in my opinion, it's just unknown. So please find bugs and exploit it. Make sure that nobody will forget it again. Finding is trivial, exploiting takes a little bit more. So many products are affected by it, and I would say research has started again. If you look at the timeline, it has started again since 2015, and chances are high that this bug class will really get into minds right now. But my honest opinion is this will never end because it will get forgotten again. Okay, that's it. Thanks a lot for attending.
Thank you very much for even keeping up with the time. So we still have time for 1 or 2, 3 questions if they are short. So if you have a question, could you please raise your hand? I'll bring you the mic. Good morning, Ottmar.
Thanks very much. So on the defensive side, what's the 1 or 2 sentence recommendation to relate to developers or operators of Java-based services? What's the shortest take care of this? What's the essence of defending against this?
For the developers, please implement a technique called look-ahead deserialization for all the object input streams you're using. You can look it up. It's from Pierre Ernst. If you are an administrator, you should think about to use something like a Java agent, where you can, for example, block calls to read object, read resolve, or to object input stream. There are several tools for that. I think it's also referenced. Yeah, look for Pierre Ernst, then you will find it. But the problem is with agents that you really need to be aware of all code paths where object serialization is used. Because the agent is running inside of a JVM and it will block everything. So if a library is using it internally, it also will block this one. So the best thing which you can do is just not use it and use JSON or something like that. And the next thing would be to implement look-ahead deserialization.